Hello, can you hear me, guys? Hello, scholars, can you hear me?
Yeah, we can hear you.
All right, so we're back. Let us see what we can do here. So, in last class, I introduced you to normal distribution, and we did some examples. Like I explained, we can, we have two options: either to use the standard normal distribution table or to use Excel. But my PDF file, I don't know what is wrong with that, and it keep giving me error. So I decided to use Excel. It will give you the same results. So since we started with that, we can just stick to that. Okay. Look at this. To refresh your memory, remember, a standard normal distribution um, is a continuous, symmetric, bell-shaped distribution of a variable. So you can see the shape of the curve. Like I explained last time, half of this is 0.5, the other half is 0.5, giving you a total area of 1. Okay. So I introduced this last Tuesday, on Tuesday, and with these examples. And let's look at this. Normal distribution as a probability distribution. So it's if you're asked to find this P of this, it is something that asking you to find the area under the normal curve for this. So let me give you an example here. So this one says find the probabilities for each using the standard normal distribution. Let's try this one here. Yeah. Okay, let's try this one. But it just came in. That's my it's a P of zero z between this thing means P of zero less than 1.45. What it means is to find the probability between 0 and 1.45 under the standard normal curve. Let me write it right here. So the first thing to make it easy for you to understand what to do, it's always better to draw the diagram of the curve 0, 1.45. Okay. Now, after that, you can be able to figure out what to do, what direction to, yeah, what kind of formula to use. Okay. So I'm gonna start drawing it. Let's start with this. Get the x-axis. Then put a curve. This is easy to draw in a paper, but in a computer, it's a little bit challenging. Oh, excuse me. And then put the center line, which is the mean. 0. It's a between 0 and 1.45. So you gotta shed that part between 0 and 1.45. Okay. So you shed this out. You share this one, should I set between 0 and 1.45? Okay. So between 0 and 1.45, since we're using Excel, let me give you the formula to use between 0 and 1.45. Okay. I'm gonna type it here so you can be looking at it as we do it. It's gonna be equal and then num.s. I want you to write these formulas down so that you don't forget it. Num.s dot dist parentheses. This is what formula you're gonna type into Excel. Z value that we are given, comma, and then the true, close the parenthesis, minus 0.5. Why do we put minus 0.5? Remember, this is it's part of the formula. If you remember when I introduced this, I mentioned that this half of this is 0.5 and the other half is 0.5. You're looking for only this portion. That's why minus 0.5 comes in. Now let us go and type this in Excel and get our answer. Okay. So let me write down the Z value. Z equals 1.45. Okay. So let's go and get the answer from Excel. So you go to Excel, type equal num.s.dist. Okay. Put the Z value given was 1.45, comma, true. Did I put true on that? Did I put true on that formula? Make sure I put true there. Yep, I did. Okay. Type true. Okay. Yeah, let's see. Yeah. Sometimes. Yeah, true. Close it. Minus 0.5. That'll give you the Z value you're looking for. I mean the area. 0.4. Write it down. 0.4265. 0.4265. That's the probability. 0.4265. Rounded. So the answer become 0.4265. I can call it 42.65% chance. I mean, any question on this? Yeah. So, okay. So between 0 and any value given, just use this formula here. Let me highlight it for you. Like I said, write it down so that you don't forget. The other one says PZ less than 1.65. At B. Okay. Oops. Let me just copy it on there. Okay. PB less than 1.65 equals, again, to find the direction, this is 1.65. Obviously, when you go to this chart, it's on the positive side. That means it's bigger than it's bigger than the 0, which is the mean. So in that case, if you want to draw it, it's gonna look like this. You say less than 0, 1.65. Okay. Now you make your chart. I'm gonna go back a little bit. So you draw your chart here. Okay. Put these people in. Okay. Then put your normal bell curve. Of course, we can make some adjustments here. Okay. Then put the center line. Right, my center line. It's right here. So between is less than 1.65. So it's gonna be this is 1.65 right here. Everything to the left is like that. So we're looking for this area. Okay. Okay. I gotta admit these people. Have the people coming in. I gotta admit them. Lion, okay. Some more person. Oh, scroll again. I think I have to scroll again, right? I'm gonna bring her in. All right. Now, Again, so you can see that they are looking for, say, less than 1.6. This is 1.6. This line represents 1.65. Everything on the left is less than that. Okay. So for that, this is the formula you're going to use since you're using Excel. It says to any of this, let me type it so that you can may write it down. Between to the left of, actually, this is the z value. You're looking to the area to the right because it says less than. So this is what you're looking for. You're going to use this formula. Equals num dot s dot dist. So you got z, comma, true. So when you're looking for the area to the left of any z value, where the z is greater than the mean. This z is bigger than the mean. It's because it's positive. Use this formula. So let's go and type it in Excel. Let me write down the number I'm looking for. It's 1.65. Okay. So you go to Excel. So you type equals num dot s dot this. So 1.65. Okay. 1.65, which is it's given, comma, true. Close it, then press the enter key to give you the area. 0.9505. Okay. 0.9505. 0.9505. So let me highlight this so that you can, write it down. When your diagram looks like this, this is what you're gonna use. Okay. Before I do the next one, any question on this? Any question? Hello, guys. Does anybody have a question on this?
No.
Okay, good then.
No.
All right, that's good. So how about if it only says P greater than? So your diagram will help you to figure out what kind of formula to use. I'm just going to copy this down here and paste it right here. Okay. Now, this give us equals. I want to give you an example, give me an example on this so that you can familiarize yourself with how to use this Excel. So that when we meet on probably on one Tuesday, we can run this thing up. Okay. But in this form, in that case, again, make your chart. Get 0, 1.65. Okay. Then I can put the line. Okay. Got yes. So I'm gonna give you the by tomorrow. I'm gonna have all this Excel formula typed in and upload it for you so they can know which one to use for different scenarios. Okay. It's gonna be here. Okay. All right. Good. So you can see, I say greater than this time around. So you got is greater than. Shape's gonna be here. Greater than. The symbol here say greater than. Unlike this one say less than, but this one say greater than. So you got this is what this it's at the tail. In that form, we say that it is at the tail. Okay. All right. Okay. And the last one. So in this case, the probability you're looking for, 1.65 as well. I look at the formula you're going to use for this one. Don't worry, I'll type up this formula so I can upload it for you, so you can now know it. So this time around, it's at the tail. Let's go. This is at the tail, and it is at the right tail. Okay, right tail. Right tail. Okay. So I'm gonna so it's at the right tail. Okay. So the right tail, I'm gonna use this. Equals 1 minus norm. Oh, excuse me. Norm dot s dot dist. So z comma true. Yeah. This type. So I'm gonna go to the Excel and do it again. So right there. Equals norm dot s. Oh, excuse me. So it's right there. 1 minus norm dot s dot dist. 1.65 is the z value, comma, true. 0.0, write this down, 0.0495. Okay. So 0.0495, and that's how you get it. So for each scenario, you have different ways of doing it. Like now, for this one, now let's do one more here. Like this type here. Let me copy it completely. But when it says here to find this area, I mean the probability of this, okay? You can just do this is how the diagram will look like. Negative 0. Sorry, negative 0, just, yep, negative 2.460, 1.75. Okay. And then you can now draw a chart. Oh, excuse me, sorry. Horizontal axis first. Then you can now draw a chart. Make your necessary adjustments. Okay. It's kind of go up a little bit. Then we can insert, put the center line. Say between these two lines. So I'm gonna be between this here and that. So that's what I'm looking for, the area between them. Okay. Yeah. So the for this type, in between two z values on the opposite side, you're gonna use this formula equals norm dot s dot dist. Okay. Z1 is the first one. I would say use the absolute values. Use the bigger one minus the smaller one. Z1 come out true minus Okay, see if it's minus norm dot s dot dist. Z2, okay, true. Okay, let me write this Z1 and Z2 down. Z1 is, okay, is negative 2.46. Z2 is 1.74. So we can just, go to Excel and put it right in. So it's going to be equals num dot s dot dist. Z1 is negative 2.46, comma, true, minus num dot s dot dist. Of course, you know that S means standard. This means distribution. So normal standard distribution. Z2 is 1.74, comma, true. Close the parenthesis and press the enter key. 0.95, but it said negative 0.95212. But you know that from the time we did probability, that the probability answer can never be negative. So Excel have this, sometimes you make this kind of error. So just know that it cannot be negative. Just write the positive part, the absolute value of it, which is 0.95212. So don't ever write negative there, because probability value can never be negative. 0.95221. Okay. So the answer becomes equals 0.9521. So this is how you do it. Like I said, I'm gonna type up the formula, set formulas, upload it for you so you can use them to try several type of this. Sometimes they might ask you they will give you the area or the probability, and they will ask you to find the Z value that correspond to it. Like this one, number 3. Say find the Z value correspond to the area below. So area is 0.4066 to the right. Okay. So because this is 0.40, that means it's between remember it's going from 0 to 1, 0.5, 0.5 on both sides. So for this type, you go to the right. This is the formula you're gonna use. Okay. Num.s.inverse area. So let us cut the first part. Part A, what it says. In that case, is a point. This basically gives you the area between 0 and 5. Between yeah, let me show you how it will look like. Gonna be 0. Okay. And then let me so because for this type, you have to make a slight adjustment before you can find the area. So to the right. This is the area you're looking for the Z value to the right. So you're gonna be oh, excuse me, sorry, mistake. Okay, this is it right here, and then you have the center line. So this thing, whenever it is close to 0.5 like this, I mean it's showing the area between 0 and that value. This is 0 here. The area is given here. So this area is already given. See, this area is given as 0.4066. Okay, and it's set to the right. That's why you put on the right. You're looking for this Z value here, the right. That's what I'm looking for. So that Z becomes, this is the area that was given. I'm going to show you. See, this is the area it was given as 0.46. So for this, it's between 0 and 5. But remember, it forgot this side. And remember, this side is 0.5. So the Z value that you're looking for should be the area should be, you have to add 0.5 to this number to be able to use this formula in Excel. So 0.5 plus 0.406. Whenever it is close to, it is in this form, between 0 and and a given value. Make this as light adjustment before you can apply the formula, which is 0.9066. That's what you're going to look. That's what you're going to use for your area. So it's on the right side. This is what you're going for the right side. Say, it says area 0.4066 to the right. So we're gonna be using this. Let me write this down. 0.4. Now it's now 0.9066. Okay, you're looking for. So in that case, so you can now look at the Excel. Let's get the answer now for this. So that our Z will now become, if you go to the Excel, like I said, we're gonna use this one. Okay, non.inverse. So equals, we got right is non.inverse dot s dot inverse 1 minus what you have 0.9066. Close it, and that'll give you the 1.32. You give you negative 1.32, but it's on the right side, so you're gonna be positive 1.32. 1.32. So gonna be so you're gonna be positive 1.32. This is on the right side. If on the left side, then you can use negative 1.32. Remember, this is symmetry. The negative sign just shows that shows left side, positive show right side. So the Excel sometimes can mix them up a little bit. Any question on this? Okay, so whenever it is close to 0.5 like this, like the second one, say left, in that case, we're going to be using this one. You made that slight adjustment. Then do it. But for those of them that are extreme right or extreme left, like this 4, this one here, you don't have to make the adjustment. So to find, and I'm going to explain it with example. Like here now, find the area. I'm going to paste it here. In this case, if I draw this kind of chart, you're going to be on the right side, on the left side. So you're going to look like this. 0. Okay. Yep. 0. Then we're going to have this. Then I'm going to put this. So, okay, tap it. Then put the center line. Then for the Z that you're looking for, so the left side. So you're gonna be negative Z. Z that you're looking for. Adjust for 0. Okay. So we can now shade spots. Maybe this. So you can clearly, this is between 0 and the Z value. Okay? By the nature of the number given. So the area given was 0.4175. And that is the area that was given in this place. Okay? So in that case, we're going to be using this formula here. So now Z equals, look at this formula right here, this first one on the left side. Number inverse, just type the area. So let me write this area down. We can go and get the formula, the Z value there. 0.4175. So in that case, we just go to Excel and type in equals norm.s.inverse and type the area on the left side. Area given was 0.4175. Close parenthesis, press the enter key. -2, sorry, we have to make adjustments. Sorry, my mistake. We have to make the adjustment because remember, this is just like the other one. This shows us only between 0 and Z. It forgot this side. So we're going to make the adjustment 0.4175 plus 0.5 that was missing. They give us 0.9175. So this is what we're going to be looking at in the table. 0.9175. So we go to the table and make the correction here. I mean to Excel, not table. Norm.s.inverse 0.9175. Close the parenthesis on this. That's 1.39. Say 1.39. So the Z value becomes 1.39. 1.39. Now, because it is on the left side, you gotta be negative 1.39. Does anybody have a question on that? Okay, no question. Good. Now, they might ask in this form, find the Z value Z value to the left of Z value to the left of the mean. Now, before I do that, I want to show you one more example before I can do that. Like this type, you don't have to make adjustments. So let me do part 6. See? You don't have to make any adjustments here. Can just type the number. Because it's 0.0239. Clearly, this is on the tail. Because it says 0.0239. So in that case, you just do the and it says make sure somebody just came in. Who is that person? Yep, there you go. So that case, you just have to just put the because it's at the right. The formula you're gonna use becomes norm equals norm dot s dot this. Okay, it's at the right one minus the area. See, because now when it is close to 0.5 like this two, you make adjustment before you can use the formula. But if it's not like this ones, you don't have to make adjustments because they are extreme right or extreme left. See? So this is part C is one we are solving. So all you just have to do is just type the formula in and put the area. So our Z becomes equals, so it says right. And write the area down, 0.0239, right, okay? You go to the Excel. What the equals, I'm gonna use equals num dot s dot inverse, because it's set to right. So you 1 minus area, which is area is 0.0209. Close the parenthesis, press enter key, give you 1.98. 1.98. Okay. Go to right. 1.98. Okay. And on it goes. I want you to understand how to use this, because once you understand the date, the rest becomes piece of cake. Okay. So this formula, don't forget. Right. I'm gonna type them in anyway for you. Now look at here. So you're gonna put it into these forms or this form that's extreme left, extreme right. But when it's close to 0.5 like this, you have to make adjustments, add 0.5 to it to get it. But when it's in this form, you don't have to do that, because it's already, that have already been factored in. Now let us try part D. I'll remove this part D. Part D will be here. I'll put right here. Let me remove this yellow signs from it. Yep, it's the area to the left. See, this one is extreme because you grab it is 0.01. That means it's really extreme left. For that, you're gonna use this formula. Let me write this Z first of all. Formula is gonna use this called left tail. Put that way. Norm dot equals norm dot s dot inverse. Then type in the area. That will give you the Z you're looking for. So in that case, our Z becomes, so I'm going to use the area. Okay. Okay, then 0.0188. Okay. So let's go and put it in. Equals norm dot s dot this. Oh, dot inverse 0.0188. Close parenthesis and press the enter key. Get negative 2.08. Okay. This is 2.08. This is negative 2.08. Okay. Now that is, when this in this extreme. Now when it is in part D, says like here, this type. So look at this type is extreme right, extreme left, because remember it's close to the 1, close to 0.1. I mean to 1. So that case again, this type you don't have to make any adjustment. Just follow the rule. It says A. I'll remove this yellow symbol. So in this case, it's on the left side. It's on the left, okay. So you use the same formula here. This formula right here. Just the answer will be negative. That's the only difference. So in that case, our Z becomes, we're given the area 0.89 or 0.8962. 8962. Okay. So we got take it to the Excel. So you got equals norm dot s dot inverse 0.8962. The parenthesis 1.26. I mean 1.26 basically. 1.26. Yeah. We normally write them in two decimal places. 1.26. 1.26. It is always good to draw the chart like I did on this ones to know what we are doing. But if you can remember that this when it is close to 1 or very, very small amount like this type, you don't have to make adjustment. Just apply the formula. But when it's close to 0.5, then it apply the formula. Now look at this one. When it is given as a percent, say here, find the z value to the left so that 98.87% of the area under the normal curve lies to the left. So this one, you can even, if you like, you can make a diagram, if you like. But you know that z area given was area given is 898.87%, which is equal 0.9887. And it says to find the z value to the left. Okay? To the left. That means that the formula you're using is this formula here. Equals norm. Excuse me. Oh, say to the left. This is 98. Okay. For any of them, any of the distance, it says find the z value. Yeah, the left. You can just use that some formula. Norm s of this. See to the left. Area. That's it. Okay. That's what we're gonna use. Which is, I mean, that z value becomes, well, it's going to be a negative number. So write the number 0.9887. Yeah. The Excel can equal norm dot s dot inverse 0.9, oh, excuse me, 9887. Okay, I give us 2.28. But it's on the left side. So you gotta be negative 2.28. Okay. So this is how you get the z value if you're given the area. If you're given the z value and you're asked to find the area, this is area, which is probability. This is how you do it. So the opposite is when you're given the area and you're asked to find the z value. You do the one starts here, which is finding the specific z value for a given area. So now this is the first one. The standard normal distribution. Let's look at standard normal distribution. The standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. So it's a standard is a normal distribution with a mean of 0 and a standard deviation of 1. So all normally distributed variable, all of them can be transformed into the standard normally distributed variable by using this formula here. Z equals to x minus mean divided by the standard deviation, where x is the data value, Z is the standard score, mu is the mean, and delta is the standard deviation. We can apply this in maybe one or two examples. So you can see how this can be done. The application of the normal distribution. Okay. Let me make this a little bit bigger than it is. Make it 18. Okay. It says here that the monthly utility bill in a city is normally distributed with a mean of $100 and the standard deviation of $12. A utility bill is randomly selected. Find the probability that the bill is less than $70. B, find the probability that the bill is between $90 and $120. Then C, find the probability that the bill is more than $140. Okay. The first thing you do is to transform it using this formula here. Let me copy this formula. That's the formula we're using for transformation. I'm going to paste it right here. And then we go from there. So first of all, I said that the mean is $100. The symbol for the mean. Okay. Mean. And then I need the symbol for standard deviation. We need these two. Okay. I'm going to make them 18. Okay. The mean equals $100. And then standard deviation equals $12. So these two we'll be using for each of these questions. Let's part A. In part A, it says find the probability that utility bill is less than $70. So for A, X equals 70. So let us transform this using this formula here. So I'm going to transform this using this formula. So we now have equals, okay, make it 18. So we have X equals 70 minus mean of 100 divided by 12, which is standard deviation. Okay. So we have, let me write this down. 70 minus 100 over 12. Okay. You can get this calculator to help us do this. I can even do it in Excel. So we got as a calculator right here, Desmos. So we got 70. Okay. Minus 100 divided by 12. Negative 2.50. Negative 2.50. So we are asked to find this is not longer X, it is no longer X, it is now transformed to a Z. So it is no longer 70, it is now negative 2.5. So I ask you to find the probability that the bill is less than $70. That means we're looking for the probability that the bill, that is Z, is less than, say I have less than here. Hopefully, yep. They put pound. Less than negative 2.5. But the fact that it's a negative sign shows that it is on the left side and that it is less than 0, which is the mean. In that case, to find the probability we're looking for, the Excel formula we'll be using is this. I call it whatever the value is is to the it's a less than, so it's on the left tail, basically. Okay. Whenever it's on the left tail, you're gonna use this formula for left tail, because something less than that, say less than this number, equals norm dot s dot this. Okay. Then you're gonna do on the left tail z comma, and then the true. That's what you're gonna use. Alternatively, you can use a table, draw the chart, and use a table to figure this out. So let me write this number down. Negative, let's say less than negative 2.5. So it's an left tail. Negative 2.50. Okay, let's go and do this. So we got let me clean all this up. So you have equal norm dot s dot this. Okay, negative 2.50, right? Yep, 2.50. 2.50, comma, true. Press enter key to give you an answer right away. 0.0062. So I have 0.0062. 0.0062. Okay. It's about 0.6.2% chance that the bill is less than $70. Does anybody have a question on this? Any question? Okay. Excellent. Excellent. Good. Now, find the probability that is between 90 and 120. So we have two x's. X1 is 90, x2 is 120. So we have transformed both of them. So I'm gonna that's part B. B, yeah, x1 equals 90, and x2 equals 120. And remember that our mean and standard deviation is still the same. So we're going to be using the same formula and the same mean and standard deviation. So I'm just going to copy it from here, paste them here. Okay. I'm still using the same formula. So that means we're going to get Z1, which will be X1, minus X1, which is 90. 90 minus 100 divided by the 12, which is standard deviation. I'll give us our Z1. Make it this in, there are two Z's now, Z1. So I'm just going to go to formula, I'll call my Z1 equals. So I'm going to go to calculate and put it to 90. 90 changes to 90. Negative 0.83. Then Z2 negative 0.83. And Z2 transformed gonna be 100, the S2 is 120. S2 120 minus 100 divided by 12. It's Z2. I'll make this adjustment. Okay. So you go to here, change this to 120. I'm gonna make Z2 here. Change this to 120. 1.67 rounded, 1.67 rounded. Okay. Let me check it out. Look at it again. 1.67 right there. 1.67. Okay. Rounded. 1.67. So when it says between 90 and 120, so it is not, it means between a negative 0.83 and 1.67, because now it is no longer 90, it is now negative 0.83, and it is no longer 120, it is now been transformed to 1.67. So looking for the probability of negative 0.83 less than z. I put double less than here. Less than, okay, z less than 1.67. Okay, that's what I'm looking for. Now, between these two z values, where I can see between two values of opposite sign, this is opposite, this one is negative, this is positive. That means they're in two the opposite side. In that case, the set formula to use would be equals num dot dist dot s dot dist. Z1, comma, true, minus num dot s dot dist. Z2, true. Okay, let's go and put this in. I have Z1 and Z2. I have Z1 is it is 0.83, Z2 1.67. Let's go and get it from this answer right away. So we have equals num dot s dot this. Z1 negative 0.83, comma, true, minus num dot s dot this. 1.67 is Z2, comma, true. Close it and press enter key to give you the answer right away. Negative, well, you say negative 0.7493, but you know that probability answer can never be negative. So you're going to write it as an absolute value of that, which can be 0.7493. 0.7493. 0.7493. Okay. Any question on this? Okay, no question. Good. So let's say find the probability that the utility bill is more than 140 then. So part C. Okay. C. Yeah, X equals 140. So you got transform 140. Okay, more than 140. I mean, it's greater than. Let us transform it. Using this formula we normally use. Formula is this right here. Well, just carry this. Okay, paste it right here. And change these things to move this 140. Now this one is 140. Okay, so I'm gonna go to the place and index calculator 140. Send this to 140. Give me 3.33. At 3.33. So it's no longer 140, it has now transformed to 3.33. And when it says more than, that means greater than. So we're looking for the probability, okay, that the z value It's more than means greater than. Okay. 3.33. Okay. Greater than. Okay. At the right tail. Greater than means 3.33 is already on the right side, which is positive. And we say greater than that, that means it's on the right tail. So in the right tail, you're gonna do I'm gonna use this formula. 1 minus num dot s dot this. Okay. Z, comma, true. That will give you the answer right away. Right there. So let's do it for this one. 3.33. So I'm taking you to Excel. So you're gonna be equals 1 minus num dot s dot s dot dist. 3.33, comma, true. Okay. Give me the answer. 0.00, 0.000, 0.0004. Make sure I got everything correct here. Yeah, 3.3, written 3.33. Here, give me uh yep, we're good. Point 0.0004. 0.0004. Point 0.0004. Okay. Now, any question before we leave? Hello, guys, are you there?
I have a question, Professor. So we have a homework assignment due on Sunday, right?
Yes, because I'm gonna extend. I'm not.
Is that
I'm
on
not sure.
Pearson?
I think it's the old one that is due on Sunday.
Is that on Pearson or is that this?
Let me see what. Let me check. Take you to the class so I can make sure I get the one you're referring to. Okay, this is the class right here. So this is the this one is due on Sunday, which is the old homework. Yes. Can you see the screen, sir? Hello?
Yes, yes, Professor.
Yeah, that's the one. This is the one that is due on Sunday. This is for the other topic we finished last week. So for this one, the homework is due next week, not this week. So because we're gonna finish this one next week. So classwork, I'm gonna put the classwork after we finish. At least I have given you the enough background information to be able to handle it. Any other question before we leave?
No.
Did you say that we're gonna have classwork due tonight?
I'm gonna put it. It's supposed to be due tonight, but I'm gonna make it to be due tomorrow night.
Okay.
Yeah.
All
So,
right. Thank you.
oh, you're welcome.
So for the
So for that
classwork, do we
classwork,
just
we're gonna use Excel.
oh
Do it. Yeah, do it in Excel. See how I did this last one, this last question.
would there be a video on everything you did or
Yeah, it's being recorded as we do it here. So I'm just gonna upload it. So
I can't read shit.
use this one that I upload today as a guide. But I'm going to upload the Excel formulas and see. Let me show you why I'm going to upload it. So you can print it out and use it to say I'm going to upload it here. So you can print it out and use it as a guide. Or you can also watch the video that we did today. Yep. Any other question, guys? Any other question, guys? For hello, scholars. Does anybody have more questions for me?
I think we should no.
All right then. So I'll see you on Tuesday. Before you go, yeah, I'll see you. Okay. You have a nice weekend, eh?
You as well. Thank you.
Welcome. Oh, this was blocking it.